Okay, so this is just a general integration review. This is nothing that has U substitution on it. If you need some with that, then go ahead and look at another video. I think I'm going to try to post another video about that. Okay, alright, so these are just some example problems. Number one. The directions for all of these are find the most general antiderivative, which is to say you're trying to integrate it. Okay, so I'll even just write them as an integral. What is the integral of 4x plus 7 dx? Okay, well, this is a pretty easy one. First of all, you could approach this a couple of different ways. The first thing that you could do is you could split this into two integrals because of the sum rule, and then the constants can come out. And when you see something like this, that means just you're integrating one. So this is going to be 4 times x squared over 2 plus 7x, and then plus some sort of constant. And then you can reduce this. 4 divided by 2 is 2, so you could write this as 2x squared plus 7x plus c. After a while, what you could just start to do is you could just start to say, hey, I'm just going to go in and integrate everything in one swoop and not split it up formally. But regardless of if you write it or not, if you integrate this without formally splitting it up, you're still splitting it up because you're using the rule. You're using the sum rule, which says you integrate each part. So whether you write this or not, that's what you're doing. Okay, let's look at another one. Okay, suppose I have something like this one. What is the integral of 2x cubed minus 2/3 x squared plus 5x dx? Okay, so here you can do the same thing like I was mentioning earlier. You don't have to write that you're going to formally split it up, but we have 2 times and then x to the power 4 over 4 because you're using the power rule here, so you're going to add one to the exponent and divide by whatever that is. And then minus 2/3 times x to the power 3 over 3 plus 5x squared over 2 plus a constant. And then you can reduce this. This becomes 1/2 x to the power 4 minus 2/9 x to the power 3 plus 5/2 x squared plus a constant. Okay. Let's do another one. Okay, suppose we have something like this. The integral of x times the quantity 12x plus 8 dx. Okay, so now what I would probably recommend doing is distributing first before you integrate. So this is because until Calculus 2, you do not know how to reverse the product rule, and this is a product, so even then you still would want to just distribute because it's easier. 12x squared plus 8x dx, and so then this is going to be 12 times x cubed over 3 plus 8x squared over 2 plus a constant. Okay, and so this is now 4x cubed plus 4x squared plus c. Okay, here's another one. Okay, how about I do something like this one? Suppose you're integrating something like x minus 6 all squared dx. Again, I would expand first. So do algebra first. This is x squared and then 2 times the product, so minus 12x and then plus 36. And then that's all we're integrating with respect to x. So this is going to be x cubed over 3 minus 12 times x squared over 2. We'll come back and simplify in a second, plus 36x plus c. So then this is going to be 1/3 x cubed minus 6x squared plus 36x plus a constant. Okay. Let's look at something a little more interesting. Okay, how about, what is this? This is like this is the fifth or fourth one. Okay, here's number 5. Suppose I ask you to integrate the square root of 2. The square root of 2, just the square root of 2. Well, the square root of 2 is a constant. A lot of people think about this as like a problem you have to solve, but it's not. It's a constant. You know, just like originally maybe when you first started learning, you think of 3/4 as a division problem, but hopefully by now you're thinking about 3/4 as a number. It's a rational number. Okay, so you could pull the root 2 out, but regardless, you're going to get root 2 times x plus a constant. That's it. It's nothing very complicated. Here's a really common one that kind of fakes people out, the integral of pi squared. A lot of people try to use the power rule here. Pi is not a variable. Not in this sense, because we're integrating with respect to x, and we're going to assume that we mean pi is the constant pi. So ultimately, you're just going to get pi squared times x plus a constant. That's it. People really try to use the power rule a lot on that one. Okay, so here's one. Number 7. What is the integral of, say, 3 times the squared root of x minus 2 times the cubed root of x dx? All right, well here, what I would do is I would first rewrite these in terms of rational exponents. So 3 times x to the power 1/2 minus 2 times x to the power 1/3 dx. And then now all you're going to need to do is do the power rule. Now, I've always told students that the way I do this is, you know, you're going to have to, like here, for example, it's a half, right? So you're going to have to add 1 to that, which is going to be 3/2, and it would be divided by 3/2. But I always tell people, and I learned this in Cal 1, it's easier to just do all that in one step. It's x to the power 3/2 over 3/2. And just that works out because you're inverting and multiplying. You know, it's the same thing as if you manipulated the x to the power 3/2 divided by 3/2, and you rewrote that as x to the power 3/2 over 1 divided by 3/2, then that's the same thing as x to the power 3/2 over 1 times 2/3, and then that's where you get what I was saying from. So it's easier if you just do it the way I said. It makes life a lot easier, and I only bring it up because I'm going to do it, and people are going to be confused, so that's why I'm bringing it up now. So this is 3 times x to the power 3/2 over 3/2 minus 2 times x to the power, and then you're adding 1 here, so this is 4/3 over 4/3, and then plus a constant, and then all you're going to do is do a little simplifying, you know. And so ultimately you're going to get 2x to the power 3/2 minus, I guess we've got 3/2 x to the power 4/3, and then plus c. And you could leave it like that, you know, if your directions, which, I mean, I'll never say that, but if your directions for some reason stated that you really needed to represent it as a, you know, rational or something like that, then you could say that it's going to be the square root of x cubed minus 3/2 times the cube root of x to the power 4 plus a constant, something like that. Either one of these is okay. Generally, this is preferred because if you need to take a second derivative, it's already ready to go, whereas this one would need to be converted, but it doesn't matter. Either way, it's fine. Okay, let's look at some trig. Well, I'll tell you what. First, let me do a couple of rational examples. What was this last one? It was number 7. This is number 8. Okay, so number 8, we've got the integral of 10 divided by x to the power 9 dx. Okay, so this is the same thing as 10 times the integral of x to the power negative 9 dx. Why? First, the 10 came out, and so then the intermediary step would be you write 10 times the integral of 1 over x to the power 9 dx. But then, because of rational exponents, the way they are, if you negate the exponent, or I shouldn't say rational exponents, but the way exponent properties in general, I mean 9 is a rational number, but anyway, the general properties for exponents would state that you can move a fraction around, but you have to change the sign of the exponent. So in other words, this becomes x to the power negative 9 dx. Just review your exponent properties, and then you'll understand what I'm talking about. Okay, so this is going to be 10 times x to the power negative 8 over negative 8 plus a constant. Why? Because you added 1 to this, and when you add 1 to negative 9, you get negative 8, and you have to divide by the same thing. That's why we divided by negative 8 plus a constant. And you got to fix this up a little bit. So you can take a 2 out of both, and you're going to get negative 5 over 4 x to the power negative 8 plus a constant. You could leave it like that, or you could write it as the opposite of 5 over 4 x to the power 8 plus a constant. Something like that. So either one's okay. It's fine either way. Either one's okay. Okay, here's a good one. What was this last number? I did number 8, so let's see number 9. Here's a good one. So suppose I have the integral of 5 minus 4x cubed plus 2x to the power 6 all over x to the power 6, and you're trying to integrate this thing. Well, here's the deal. Remember, you can split a numerator with addition and subtraction, but you cannot split a denominator. So if this was reversed, then you'd have to do something else, like probably partial fractions or something, which you learn in calculus 2. But with an example like this one, you can split the numerator into 3 different terms, and so ultimately you get three different terms, like I said. So you get 5 over x to the power 6 minus 4x cubed over x to the power 6 plus 2x to the power 6 over x to the power 6 dx. And then when you simplify this, you're going to get the integral of 5 over x to the power 6 minus 4 over x cubed plus 2 dx. That's it. So now you just have to, well, I guess, yeah, so then probably the next thing I would do is rewrite this as 5 times x to the power negative 6 minus 4x to the power negative 3 plus just the 2. And then now I'm just going to integrate the whole thing. So you're going to get 5 times x to the power negative 5 over negative 5 minus 4 times x to the power negative 2 over negative 2 plus 2x plus a constant. So now this negative and that negative can make that positive, and then 4 divided by 2 is 2. This negative is going to come out, but then a 5 divided by 5 is 1. So you get negative x to the power negative 5 plus 2x to the power negative 2 plus 2x plus a constant. And you can leave that alone. I mean, you're good. You just leave it alone. It's fine. You could rewrite them as fractions if you'd like. All right, let's look at some with trig. Well, I'll do this one. What is this? This is number 9. Number 10. So number 10, the integral of, we have 1 plus t plus t squared, and it's all divided by the square root of t dt. Okay, so this is equal to, you can do the same kind of thing, split it up. So you get 1 over the square root of t plus t over the square root of t plus t squared divided by the square root of t dt. So this is the same thing as the integral of t to the power negative 1/2. All I did is just use my exponent properties there. The square root of t becomes t to the power 1/2. To move the 1/2, or to move the t to the power 1/2 to the top, you can do that. You just have to change the sign of the exponent. And then plus, so for this is going to become, this is t to the power 1 minus 1/2. Let me show why, because you guys are going to get lost. Okay, so first of all, this you could write as 1 over t to the power 1/2, because the square root of t is t to the power 1/2. Plus, then this is t over, and then this is t to the power 1/2. And then plus, then this is t squared divided by t to the power 1/2. Alright, so now we're going to use exponent properties, which say that this is going to become t to the power negative 1/2 plus, then this is going to become t to the power 1 minus 1/2 plus, then this becomes, that's a plus, t to the power 2 minus 1/2 dt. I'm just using exponent properties. It says that like x to the power a divided by x to the power b is equal to x to the power a minus b. That's what it says. Okay, so then this is the same thing as, we can just, well, I guess let me clean it up. So this is t to the power negative 1/2 plus t to the power 1/2, and then plus, and then 2 minus 1/2 is 3/2, so t to the power 3/2 dt. So now just go ahead and integrate it. So this is t to the power 1/2 over 1/2 plus t to the power 3/2 over 3/2 plus t to the power 5/2 over 5/2 plus a constant. So ultimately this is now 2 times the square root of t plus, you have 2/3 times, so that's going to be the square root of t cubed, and then plus 2/5 times the square root of t to the power 5. Oops. T to the power 5, and then plus a constant. And you don't have to write it this way. You could write it like just with fractions and just, you know, you could write it like that. You could leave it like that. That's fine. Okay, let's get to some trig. All right, so yeah, like I don't really have the standard integral, the standard trig integrals memorized, but I have the derivatives memorized. So you'll see that I always go forwards and backwards. You'll see what I mean. Like if I'm integrating the cosine, for example, I'll say, okay, well I have the integral of the cosine. So I'll say, okay, well I know that the derivative of the sine is the cosine, so that must mean that the integral of the cosine is the sine. So indefinite integral of the cosine is the sine plus c. Okay, so let's go through another one. What number was this? 10. Okay, so this is number 11. And so so here's one. I have the integral of 2 times the sine of theta minus the secant squared of theta d theta. Okay. So let's go on and integrate this thing. Well, you're going to need to split this one up. Or, I mean, you don't have to, I guess, but I'm going to split it up. Okay. So 2 times the sine of theta d theta minus the integral of the secant squared of theta d theta. And you pull the 2 out. So the 2 can come out. All right, so here's what I have. I have that the derivative of the, I know that the derivative of the cosine is negative sine. So if I put a negative here and then a negative here, then I'm now integrating negative sine, right? So we know that the derivative of the sine, the derivative of the cosine was negative sine, so that must mean that the antiderivative of negative sine is the cosine. So this is negative 2 times the cosine of theta d theta. To a certain extent, it's a little bit of a u sub kind of deal, but not so much. And then minus, and then minus, I know that the derivative of the tangent is secant squared, so the antiderivative of the secant squared is going to be the tangent of theta plus a constant. And that's it. That's sufficient. All right, number 12. Okay, here's one. So suppose you have the integral of 8 times the square root of t minus the secant of t times the tangent of t dt. Alright, so first of all I can pull the 8 out. I have the integral of t to the power 1/2 minus the secant of t times the tangent of t dt. Okay. Well, let me see. I would definitely need to split this one up if I'm going to pull that 8 out, because otherwise I would need to put a 1/8 here to balance it out because I'm factoring. So, yeah. So let's just do that. Otherwise, I'm illegal. Okay. So I've got 8 times, and I've got t to the power 3 halves over 3 halves. And then minus the derivative of the secant is the secant times the tangent, so the antiderivative of the secant times the tangent is the secant of t plus c. And now this, you can clean this up a little bit. Okay, that's kind of the deal. I mean, it's sort of just the same thing. So just review. I mean, that's a bunch of problems I worked, so just try to make sure that you review, okay?